Perfect. Let me just minimize the GoToMeeting. Okay. Hey, everyone. My name is Erik Bohnhorst. I work at NVIDIA. I used to be a solution architect working on VDI and RDSH environments at HP before joining NVIDIA around about 5 years ago, where I started as a solution architect in Germany as well. So probably from my pronunciation, my accent, sometimes you will hear my German. And now I'm located in the US now, and I run the performance engineering team, and I'm part of the broader technical marketing team at NVIDIA. Today, I will have you for the next 2 sessions. So this one's about choosing the right NVIDIA GPU for your workload, and the next session is about how we at NVIDIA measure user experience in VDI and RDSH environments. So let me try to move to the next slide. Here we go. So before going in more detail around what GPU to choose, I do want to make sure that everybody is aware of the different vGPU products that we have available. So there are, on top of all the Tesla GPUs that you can choose from, there are 3 software editions that we have at the moment. One is what we call the NVIDIA Grid Virtual Application Software Edition, which most people refer to as VApp. It's basically our software edition to run XenApp and equivalent RDSH environment. We also have Grid VPC, which is targeted for the typical VDI use cases. So what typically would be a knowledge worker type user, or what we call a digital worker. And then third but not least but not last, no, the other way around, I guess, is our Grid Virtual Workstation offering, and which is also often referred to as QVDWS, so our Quadro Virtual Data Center Workstation, which is basically the software edition that allows you to have the Quadro functionality and performance on top of a virtual GPU. So these are the 3 software editions or products that we have, and then we have a variety of GPUs that you can run virtual GPU and these software editions on. So this is kind of the current portfolio that you have available to choose from. Right, you can see from the naming, starting with the V100, that's a GPU based on the Volta architecture. The RTX cards are actually Quadro cards, not Tesla cards. They are based on the Turing architecture, which is our latest architecture. The P40 is based on the Pascal architecture, which is the architecture right before the Volta architecture. We have the Tesla T4, which again is based on the Turing architecture. And then we have the M10, which is based on the Maxwell architecture, which is made for purposely built and the most cost-effective solution for our knowledge worker type users. And then we have the P6, which is the GPU made for blades. So many GPUs to choose from, and customers very often just don't know which GPU to choose for their workload. So I will try to spend the next couple minutes on helping everybody to understand the portfolio and when to choose which GPU, because there's a reason for every GPU in this lineup. So just having a look again at this slide, you can see that they have very different amounts of CUDA cores, and a CUDA core is between generations might change, right? They are architecturally different. So a CUDA core in a Turing architecture, right, might be faster than one in the Volta architecture or the Pascal or Maxwell architecture. So it's important to not only look at the CUDA cores as just a number, but also compare architectures. Then there are different engines on the GPUs these days as well. So we have tensor cores. So these are cores, or is a compute engine that allows you to run AI algorithms very effectively and very fast on these GPUs. So you can see that the Volta, so the V100 has 640 tensor cores, and the RTX cards have quite a lot of tensor cores as well. And then, of course, the T4, because it's a Turing card as well. So if you are interested in running multiple workloads, during the day, maybe different workloads, or you have an application that leverages some part of AI components. So we see that more and more in the media and entertainment world, for example, there's AI-based denoising. and so on. Right, so make sure to choose a GPU that has tensor cores. RT cores, so something that was introduced with the Turing architecture, and RT cores is basically a hardware engine on the GPU to do ray tracing. And ray tracing is a way that, or is a technology that has been out there for many, many years. But this is the first time that there's dedicated hardware to do it, to allow real-time ray tracing. So it allows you to calculate the light very effectively, very efficiently, very fast, which results in high frame rate for real-time ray tracing applications. So something, again, that is mainly used in the media and entertainment market segment. So again, if you're one of those customers looking at applications like that uses a renderer that makes use of RT cores, right, choose a GPU that has those. Then you can see a variety of memory sizes, so frame buffer, right? And frame buffer, again, might be, right, the size is important, but then also the type of frame buffer is important. So you can see on the V100, we have HBM2 memory, which is very, very fast memory. And then we have on the RTX cards, we have GDDR6 memory, and then on P40, GDDR5, et cetera, et cetera. So important to take into account because it has an impact on performance. And then, right, they have all different form factors, which is interesting. Power, which is important to take into account. Thermals are very important. So if you look at the thermals, you can quickly see that basically every board here is a passive core except the quadro cards. So except the RTX 8000 and the 6000. Reason being, they're quadro cards. Quadro cards are typically actively cooled cards because they typically go into workstations. But these cards are now certified on servers as well. And probably the most dominant server out there that supports these today is the DL380 Gen 10. So you can equip a DL380 with those cards. And then from a vGPU software edition standpoint, every GPU except the quadro cards supports all virtual GPU products. The RTX cards, and I will now dive into a little bit more about where to use them, only the Quadro VDWS software edition is supported. So the Quadro cards are purposely built GPUs for the media and entertainment sector. Those customers typically require a lot of frame buffer. So that's why you see the RTX 8000 having 48 gigabyte of frame buffer. Whereas the RTX 6000 has 24 gigabytes of frame buffer. If you just look at all the other specs between those two cards, you will see they're basically the same. So it's really, think about it as it's the same card, just one has more frame buffer for those customers that need the additional frame buffer, right? So choose the RTX 6000 and the 8000 if you are an M&E customers, if you require the large amount of frame buffer. Otherwise, there are other cards in the portfolio which are more appropriate. I will speak quite a lot about the T4 during the next couple of slides, and I don't have many slides because the T4 is probably the best universal GPU we have in our lineup. You can see that the T4 has not only CUDA cores, but it has tensor cores and it has RT cores. It has quite a lot of memory. It is a 70-watt GPU. It's a single slot card. And it doesn't require additional power cable. So you can put multiple of these cards into a server. So the big three servers, for example, the DL380, the R740, or the Cisco C240 M5, they support a large number of these T4s. I think up 6, sometimes even 7 of those. So think about it this way. Instead of buying a very big GPU like the V100, like the RTX cards, like the P40, why don't you choose 2 T4s, right? They take away the same amount of slots in the server, but you actually get potentially more frame buffer, and you're able to split the GPUs across, you're able to split the users across GPUs, which ultimately ends up in having better performance per user, because the V100, as an example, isn't necessarily twice as fast as a single T4. So, right, and it's actually a very cost-efficient solution. So that's why we focus at NVIDIA and why we tell our customers, right? If they don't really know what workload they're looking at, what utilization they're currently having, what the right GPU would be, T4 is a great starting point for the various workloads. Okay, so the T4 was announced right, already a couple months back, but just to give you a little bit more sense on the T4, because we focus so much on the T4, and I think for the right reasons. It's such a universal GPU, right? It's not able to cover every workload because it doesn't have the performance of a B100 or a P40, but it's not that close off depending on your workload as well. So for typical graphics based on spec Q-curve as an example, the P40 might be around about 45 to 50% faster, but comes at a different price point as well. So you could actually purchase 2 T4s probably for the price of a P40, and you would get overall more performance for the same price. So the T4, great fit, right? If you're thinking of looking at the M60, which is a double width, but also a double GPU board, right? Think about choosing 2 T4s instead, right? You will just get more out of it. And then, right, it's just a good use case for various other workloads. It's great for inferencing as an example, right? Because it has the tensor cores. It's great for, well, it's good for training, right? It has around about a third of the performance of a V100, but again, at a very different price point. So if you are interested, or if you as a customer or your customer is interested of doing, let's say, some kind of VDI workload during the day, so a knowledge worker type workload, or a professional app, so Quadro type workload during the day, and wants to reuse the GPU, the compute resources overnight, the T4 is a great choice because it has these tensor cores. And then in addition to, for the VDI type workloads, it has support for VP9 decode and H.265 encode, which is something that doesn't necessarily is available in the M10. So if you have workloads that could make sense of those, if you have a lot of video watching, YouTube watching, which is VP9 mainly, then the T4 would be a great choice. So it's a universal GPU in the broader sense, which can cover most of the use cases, not necessarily has the best performance, but has good performance. So different, or just focusing a little bit more on the Quadro workspace. So again, professional applications, and we've heard other speakers today mentioning already some of these applications. But if you are a Dassault CATIA user, a Siemens NX user, if you are a PAX Diagnostic, an Adobe user, the T4 is a great choice. As you can see here, and I try to visually make it transparent, and the T4 just covers a huge spectrum of use cases today. It's good enough for many of the use cases to provide optimal performance and user experience, but not for everyone. So right, there are exceptions when you have to move up the stack to go to a P40, an RTX board, so an RTX 6000 or 8000, or even the V100, especially if you're looking for a double precision compute type workload. Traditionally, we do see that most customers are currently looking at or are virtualizing users or moving users into the data center that can be accompanied with the T4. So again, T4, right? T4 is just a fantastic starting point. If you are looking or trying to understand what GPU to choose and you really don't have an idea, again, T4 is a very high chance that it's the right GPU for you to move forward, right? And then there are the exceptions when you just need the additional performance that a T4 doesn't have. And then you move to the P40. In the case of media and entertainment, the RTX cards are the right GPUs. They have very high performance, but they also have the frame buffer and the RT cores that are required, right, to serve that market. And right, more and more renderers in those market spaces are now adopting or leveraging the RT cores, and will be over the next couple years as well. Okay. So we've done, my team, we've done a lot of testing and figuring out what the best options or combinations between CPUs and GPUs are. And I just want to share our learning. So for Quadro type workloads, so again, the professional applications, the T4 again, is the optimal GPU for almost every workload, right, with the exceptions that I mentioned. We've tested multiple CPUs, and the Intel Xeon Gold CPU, especially the 6254, is a great choice. And being a great choice because it has many cores, so it runs at, I believe, 18 cores and has a base frequency of 3.1 gigahertz. So I think Ruben mentioned it earlier during the keynote. There are some applications, right, that are just single threaded, and you need to have the base frequency, right? The frequency is more important than the number of cores to serve those users well. So this CPU is a great balance for these workstation class users, because it not only has the required frequency. So very often we hear from ISVs that 3 gigahertz or close to 3 gigahertz is wanted or expected, but it also has many cores, which allows us then to put many users on the system. So typically today we see customers looking at 4 to 6 Tesla T4s, mainly 60 Tesla T4s for the Quadro use case, with exactly that CPU running applications like CATIA, Siemens NX, SolidWorks, etc. For Grid VPC, and again, this is our knowledge worker / digital worker, how our marketing team calls them, the M10 and the T4 are the best choices there, right? You can use other GPUs as well, but they won't be as cost effective. And the M10 is actually the most cost-effective solution in our portfolio. The T4 is another option, right? You will pay, or the cost per user will be a little bit higher using the T4. But for those users that have that want to reuse the GPUs at night for compute workloads, as an example, or want to standardize on one GPU across the board, the T4 would then be a better choice, because the M10 just doesn't have enough performance for most of the Quadro type workloads, and it's definitely not for the compute type workloads. And we've tested with the Intel Xeon Gold 61 and 6248 CPUs, so the Skylake and the Cascade Lake CPUs, and we see those CPUs to be the optimal fit. We haven't tested any of the new AMD CPUs yet. We only tested the EPYC 7501 CPUs in the past, and they've been great, right? And our NVIDIA GPUs work with those CPUs. We just saw that the TCO was a little bit better on the Intel CPUs, which was surprising, but that's what it was. We typically see, and you will see from OEMs in this case HP, Dell, Cisco, and right, all the others, that there are bundles out there that basically have 4 or 6 T4s bundled with our software editions at a reduced price. So in case you're interested in those, have a look and send me an email or ask your OEM. And for Grid V apps, the M10 and the T4 again would be the ideal choice, mainly because frame buffer is the limiting factor here. So you want to make sure that you have enough frame buffer, and the M10 and the T4 just provide a good amount of frame buffer at the best cost in our lineup, and why those are the GPUs that are preferred. So I have, I think, 2 more minutes. So I will skip 1 or 2 slides. I just want to share, because I was kind of pounding on the T4, I do want to share some performance numbers that my team has gathered on the T4. So if you are interested, right, if you as a customer or your customer is interested in running or leveraging a GPU for multiple workloads, inferencing works really well. So we have a 25x faster or a speed up in comparison to a CPU virtual machine. And this is in line with what the physical Tesla team is seeing when you don't use virtualization. So inferencing is an interesting one, right? Then again, Grid VPC is an interesting one. And then again, the right comparison, in case you're interested in using a T4 for the knowledge worker / digital worker use case, make sure that you do the right comparison, which would be one M10 has 4 GPUs, can serve up to 32 users really, because it has 32 gigabytes of frame buffer shared across the 4 GPUs, right? Each GPU having 8 gigabytes. And a T4 has 1 GPU and has 16 gigabytes. So you can serve the same number of users. So two T4s in comparison to 1 Tesla M10 would be the right choice. There are a couple Reasons to choose otherwise the T4 over an M10, right? If you need more than 1 terabyte system memory in the server, that is not supported with the M10. That support started with the Pascal architecture, so Turing, which came later, has it. Right, and then from a power perspective, the T4 is interesting, or it's better than an M10 as well. But again, the M10, if you're just looking for the lowest TCO, M10 is the right GPU, and right, will be there for quite a long time. Right, there's no end of date planned. Okay, I do want to share a couple of resources before we move to the next presentation. If you need information about sizing, we've created some sizing guides for Siemens NX, Dassault Systems CATIA. There's a best practices guide for digital workers or digital workplace. So, right, in the broader sense, that's knowledge workers. So have a look in case you are interested.